Alright, boys and girls, welcome back to the drive-thru for this special Valentine's edition brought to you by the deli. Special shout out to everyone that loves out there. It really is quite good to love. Not like just about boyfriends and girlfriends, because that's usually not even really about love. It's actually people that care about each other and that type of love. Alright. And it certainly is like a manufactured holiday. But you remember that like the 4th of July is also now a very manufactured, like the advertisers will get you whether you know it or not. So you might as well just take today to love. All right, here we go. We're going to go over the harder ones from this worksheet to help you get off to a good start. So we're going to start with number 10. Graph the relation and its inverse. So the relation we're just going to call f of x, okay? And we'll make a little table here. So we want to pick the best values we can. 0 is a good place to start. 0 plus 2 squared is 2 squared. You get 4, okay? Let's put in a negative 1. And let's see, negative 1 plus 2 is a positive 1. You get 1 squared, and you get 1. Let's put in a negative 2. You get 0 squared, and you get 0, okay? How about a negative 3? Let's keep going until it gets ridiculous. Negative 3, you get a negative 1 squared, and you get a 1. Negative 4, you get a negative 2 squared, and you get a 4. So, if just kind of ignore these. We have our table as 0, 4, negative 1, 1, negative 2, 0, negative 3, 1, and negative 4, 4. So we're going to graph those. 0, 4. Negative 1, 1, negative 2, 0, negative 3, 1, and negative 4, 4. And now you'll see okay. Now to graph the inverse, we're going to call that f inverse of x. And we just switch them. 4, 0, 1, negative 1, 0, negative 2, 1, negative 3, and 4, negative 4. Okay, 4, 0, 1, negative 1, 0, negative 2, here, close enough. And there's that one. Okay? Notice, again, if you're doing these right, there should be a diagonal line of symmetry that you could always create and envision. It's always that diagonal line, y equals x. Okay, the other requests we've had have been 12. So we'll start with 12. For each function, find the inverse, the domain, and the range. Okay? Well, this is another way to write this is y equals x over 6. Do you realize those are the same thing? Okay, so are there any values that I'm not allowed to put in? Remember, domain is your input, range is your output. Okay, are there any values that I'm not allowed to put in for x? So that's just how you write very quickly all real numbers. Okay, that's all that means. That weird R is all real numbers. It's like 2 dashes and a capital R. Yes? Well, you weren't listening. It's the same thing, okay? X over 6 is the same thing as 1/6 x. So I wrote it the way that I'm familiar with, that I like to write it. Okay, all good. The range, is there any value that I cannot get for y? There's not. we can get anything we want for y, depending on what we put in. So the range is also the reals. So that'll change. So that's a good one to do. All right, so now we want to find the inverse. To find the inverse, we switch the x and the y, and we solve it for y. So what do we do to solve this for y? Multiply both sides by 6, and you end up getting y equals 6x. Okay? The domain for this one is all real numbers, and the range for this one is all real numbers. So that's a start. How about we look at 14 next? Okay? We're going to rewrite this as y equals x squared minus 2. All right, so this domain and range is a little bit harder. Are there anything that I'm not allowed to put in for x? Nope, I can put in whatever I want for x. Now, you got to be a thinker here to come up with the range. When you put in a value for x, what's being done to it? It's squaring it. What happens when we square any number? It multiplies by itself. It's going to be positive. That's what I was looking for. No matter what I put in for x, it's going to be positive. Okay? So what if I put in, well, there is one exception to that. What if I put in a 0? Then it's going to be 0. So the lowest result I could get is squaring 0, right? So when we put in a 0, you get 0 squared minus 2. What do we get? Negative 2. That means the smallest value on our output is going to be negative 2. Does that make sense to you? That the smallest thing we can possibly get is negative 2. If you think about this graph, okay, just this, it's going to look like this. Right? Does that make sense to you? It's going to be a parabola shifted down 2. Well, what's the smallest thing we can get for our y? Negative 2. So this is y must be greater than or equal to negative 2. Okay? That's all. There's a lot of talk with no work because I can't really show any work on that. All right, so now let's find the inverse. So we call it x equals y squared minus 2. We're going to solve this thing for y. So add 2 first. You get x plus 2 is equal to y squared. Square root both sides. And you get y is equal to plus or minus the square root of x plus 2. This is not a function because of the plus or minus. Okay? And our domain, well, you can't have a negative under the square root, right? So we could put in a negative 1 because we'd still have a positive under the square root. We could put a negative 2 in because we'd have a 0 under the square root, but we couldn't put in anything less than a negative 2. So x has to be greater than or equal to negative 2, okay? And now, I think, since y is plus or minus, our range, y is going to be all reals because it's plus or minus. Okay? And that's tough. I'm not super concerned that you're getting every single domain and range exactly right, but I am concerned, or it is important that you think about it. It's okay if you make some mistakes, okay? How about we do one more? We'll do number 16. Is that okay? So for 16, let me stick with my same coloration. So y, I know, I'm just giving myself some room. Y equals square root of x minus 1. The domain. I can't have a negative under the radical, so I'm not allowed to put in 0 for x, right? I am allowed to put in what? 1. Very good. So x has to be greater than or equal to 1. For the range, whoops, overdoing it with my special R's. For the range, can y ever be negative? It cannot. So y has to be bigger than or equal to 0. Okay? Now, I'll switch the x and the y and solve it for y. And now hopefully you can see why we are learning this in the order that we are. We're going to square both sides. So you get x squared. Have a great day. Is y minus 1. So y is x squared plus 1. That is a function. The domain is all reals. And the range, is y has to be bigger than or equal to 1. Have a great day. Why does it have to be bigger than 1? Oh, because I'm solving this for y, so I have to add a 1 to both sides. That gets rid of it, okay? Good question, Jen. That's what I'm talking about. Boom!